Hello everyone. In our previous video, we have discussed about clipping and the types of clipping. Now we will discuss one type of clipping that is called as line clipping. So we will discuss in this video one type of line clipping algorithm called Cohen Sutherland line clipping algorithm. So this algorithm is used in computer graphics to remove or to reject the line or the portion of the line that present outside the clipping window. Suppose we will take four cases. In these four cases, we have a clipping window and the line segment. In the case A, we will see the position of a line segment in the XY plane. Okay, in this XY plane, we have a clipping window. This is called as what? Clipping window. In this clipping window, in this example, we have a line segment, right? This line segment completely resides inside the clipping window. So, we don't want to do a line clipping in this case. Okay, because the line is completely visible inside the clipping window. We will go for the case B. In the case B, in the XY plane, this is our what? Clipping window, right? So our line segment which resides like this. In this line segment, one end point of line segment is inside the window, another end point of a line segment is outside the window. So in that case, we need to find the intersection of the line segment. So using this intersection and the another end point, we need to clip this. We need to reject this portion of the line. So this is called as what? Line clipping. To perform this kind of line clipping, we need to discuss or study the algorithm. The algorithm is called as Cohen Sutherland line clipping algorithm. This algorithm is used for reject a line or clip the line or the portion of the line that presents outside the clipping window. Okay, then we'll go for case C. In the case C, what is happening? The line segment completely resides outside the clipping window. In that case, we don't want to perform a line clipping because our end point of both line segment and portion of the line segment completely present outside the clipping window. So this type of line segment is negligible. We don't want to perform line clipping here. We'll go for the case D. In this case, the line segment will appears like this. Suppose appears like this. Here the end point of line segment is outside the clipping window, but the portion of the line segment is present inside the clipping window. In that case, we need to find the intersection as per Cohen Sutherland line clipping algorithm. Then for example, we'll name the line segment A, B, and this intersection will be named as A dash, and this will be what? B dash. So as per the algorithm, we need to clip the line portion of the line A to A dash as well as B to B dash. So in this case, we need to perform a line clipping B to B dash, A to A dash. For that, we need to use an algorithm, one type of algorithm, Cohen Sutherland algorithm. Now we will discuss how this algorithm will work. As per the algorithm, it will divide the dimensional space. It may be 2-dimensional or 3-dimensional space into 9 regions. Why it has to divide the 9 regions, the dimensional space? To determine whether lines or portion of the lines is visible inside the clipping window or not. So now we will, as per this algorithm, we will take an 2-dimensional space. Okay, suppose this is a 2-dimensional space. So this space we need to divide into how many regions? 9 regions as per the algorithm. So this is our 2-dimensional space. This 2-dimensional space, as per the Cohen Sutherland line clipping algorithm, the 2-dimensional space, this is what? 2-dimensional space XY plane, right? And this XY plane we will divide into 9 regions. After dividing into 9 regions, as per the algorithm, we will name the region name. For example, this is region 1, region 2, region 3, 4, 5, 6, 7, 8, 9. So then what algorithm will do? Algorithm will divide the XY plane into 9 regions. So after dividing this, region 5, this is called as what? Clipping window. This is called as what? Clipping window. And the size of this clipping window as per the x-axis, along the x-axis, this is called as x minimum, this is called as x max. And on the y-axis, vertically if you want to see, the position of this clipping window, that is region 5 will call as what? Clipping window. On y-axis, this is called as y minimum and this is called as what? Y max. So that is our clipping window lies between x minimum and x max along x-axis. Along y-axis, this clipping window lies between y minimum and y max. This how, as per the algorithm, the xy plane is divided into 9 regions. After dividing into 9 regions, each region is assigned with 4 bits, 4-bit code. 4-bit code. For example, bit 1, bit 2, bit 3, bit 4. So this position of the region code is assigned with 4-bit code as per the pattern top, bottom, right and left side of the clipping window. First we'll discuss which portion of the XY plane is called as top, bottom, right and the left. I will explain along with this example. See, this is our clipping window, right? So the portion above the clipping window, so this is called as what? This is called as what? Top of the clipping window. So this is called as bottom of the clipping window. And this is the left side, right? Left of the clipping window. And this is called as what? Right of the clipping window. So I'll repeat again. Top, this will be bottom and this will be left and this will be right. So all this top, bottom, left and right of the clipping window we have named as TBRL, that is top, bottom, right and left. Okay, based on this pattern, each region will assign with a region code or bit code. Okay, we'll start with this, assigning a bit code for each region. What's the pattern based here? What's the pattern here? We have planned top, bottom, right, left. Okay, so now we'll see where this region 1 is locating. It is locating on the top, right? So the top bit will be assigned into 1. Is it locating in the bottom? No, this is not in the region 1 is not in the bottom. Actually, this will be the bottom, right? Region is not in the bottom. So bottom bit will be 0. Is it region 1 is locating in the right side? No, it is locating in the left side. So the right bit will be what? 0. So L stands for what? Left. This region is locating, yes, left side of the window. So this bit will be 1. On the basis of top, bottom, right, left, we have assigned a 4-bit code into region 1. Similarly, for region 2 also we need to assign the 4-bit based on this, right? So where it is locating this region 2? On the top of the window. This is the what? Top of the window. Yes, this top bit will be assigned into set to 1. Is it in the right side? No, 0. Is it in the left bottom? No, 0. Is it in the left side? No, bit will be what? 0. This is how the 4-bit is assigned into region 2. Now we'll go for region 3. Okay. This region 3 is locating in the top of the window. Yes, this is your window, right? This is called as top of the window. Region 3 is locating in the top of the window. Yes, this bit will be what? 1. Is it in the right? It is in the right side of the window. This is called as what? Right side. This is your clipping window. This region 3 is locating on the right side of the window. So this bit will be what? 1. Whether region 3 is in the bottom of the window? No. So bit will be 0. Region 3 in the left side of the window? Actually this is left side, right? So this is locating in the left side of the window? No. So the bit will set to 0. This is how the 4-bit code is assigned into region 3. Similarly, we'll assign the 4-bit code region 4. Okay, based on the pattern top, bottom, right, left. Okay. Is it region 4 is locating on the top of the window? Actually, this will be the top, right? This will be the top. But R4 is not in the top, so it's middle, right? So the bit for T will be 0. Is it in the bottom? Actually, this will be the bottom. Is this R4 will be the bottom? No. So bit will be what? 0. Is it your R4 in the right side of the window? No. 0. Is it your R4 bit is left side of the window? Yes, it is left side of the window. The bit will be, L bit will be now what? 1. This is the region code for a R4 region or bit code for a R4 region. Now we'll go for region 5. This is the center of the 9 region, and this R5 is called, as we already discussed, clipping window. We'll assign a 4 bit for this clipping window or region 5 based on this pattern. Is it locating in the top of the window? No, 0. Right side? No, 0. Bottom? No, 0. Is it left? R5 is in the left side of the window? No, 0. So we need to observe here the clipping window bit code will be what? 0. So this is the concept we will use in a line clipping algorithm. When bit code of a region will be 0, that indicate that our line segment completely visible inside the clipping window. Okay, next we'll go for region 6. Okay, for the region 6 we will assign bit code. Is it your region 6 will be present in the top of the window? No, actually top of the window will be this, right? It is region 6 is locating in the, where it is locating in the center. So top of the window T will be what? 0 in that time. R6 is locating, is it in the right side of the window? Yes, it is right side of the window. So this bit will be what? 1. Is it in the bottom? No, 0. Is it left side? No, 0. So this will be what? Region code for a R6. Similarly, we'll go for region 7. Region 7, is it locating on the top of the window? Is it locating on the top of the window? No. So what is the bit will be here? 0. Is it region 7 is locating on the right side? No, where it is? Actually, it is in left side. So R bit will be 0. Bottom, region 7 is locating in the bottom of the window. Yes, it is locating in the bottom of the window. So we'll call as this is what? 1. This is what? 1. Is it locating region 7 in the left side of the window? Yes. 1. Okay, next we'll go for R8 region. Top, bottom, right, left. Actually here is what? Bottom, here is what? Left. Bottom will be 1 and right will be 0 and left side will be 1. So region code of this region 7 0 1 0 1. Okay, R8 is R8 is locating in the bottom, right? Is it in the right side? No, 0. Is it in the left side? No, 0. It is in the right top? No, 0. So it is locating where it is locating? In the bottom. So B bit will be set to 1 and remaining bit will be 0. We'll go for region 9. Top, bottom, right, left. R9 is locating bottom, right, and R9 is locating on the right side of the window. So 1. And the top and the left will be assigned into 0 0. This is how each region 1 to region 9, 4 bit is assigned. How it is assigned 4 bit? Based on the top of the window, bottom and left and the right. So now we will check this bit in another way with the following conditions. With the following condition. The conditions are like this. Top bit will be set to 1. Top bit will be set to 1 if this is our top, right? If along y-axis this will be what? Bottom, right? And this will be what? Left, and this will be what? Right of the window, right? Actually left will be this side. Left side of the window, right side of the window, bottom of the window, top of the window. So top and bottom of the window we will check along y-axis. So I'll take as y. Suppose I'll take a position x comma y in the region 1. Okay, here in the region 1, how this top, bottom, right and left will be bit will be assigned 1 or 0, we'll discuss along with the condition. Okay, so Now I'll check with the top. Top I need to check along y axis. So I need to check the position of the y here. Right? If y is greater than y max. Look at this. This is our y. If y is greater than y max, if that condition is true, then what we will do? Top bit will be assigned into 1. It will be set to 1. See, top bit will be what? 1. Okay. Now I'll go for bottom. So bottom, top and bottom will check along what y axis. So I need to check what is y value. Okay. Bottom is set to 0. I'm talking about region 1, right? If y is lesser than y minimum. This is my y, right? This is what? Y. This is y. And this y is lesser than minimum? No, false, right? So that is why bottom bit is set to 0, right? So next we'll go for right. So left and right will check along what x-axis. So I need to check whether x will be lesser than x minimum, x will be greater than x max. Depending on that, we need to check right and left will be 1 or 0. So I'll go for now the bit R. R is set to, according to region 1, R is set to 0 because if this is what x, right? If this x is lesser than x minimum. This is my x minimum. Lesser than x minimum. X is lesser than x minimum. Right? So the condition is what? Okay, this will be what? L. The x L. Left side we need to check. So I need to check what L. Yes, condition is true. In this case, L bit is set to what? 1. Okay, L bit is what? 1. Now we'll go for bit R. So R is set to 0 in the region 1 because my x value is there, no? X. This is greater than x max. I'm checking. Is it greater than x max? No. The condition is false. That is why R bit is set to 0. In this way, by checking these 4 conditions, you can assign the bit 1 or 0 for the top, bottom, right and left as per this algorithm. Thank you. In the next video, we will discuss the example of Cohen Sutherland line clipping algorithm.